In this video, I'm going to show you how to connect the spectrograph to the telescope in order to record your spectra. At this point, you have already arrived at your destination and you have set up your portable table. You have the spectrograph and the power supply on the table with the dehumidifier still running, and you have your laptop on the table. We've also already set up the telescope and aligned with the North Star. It's very important that you align with Polaris because this is an equatorial mount and the motor will run through right ascension. And if you don't have it exactly lined up with Polaris, it's going to, the stars in the field of view are going to drift through the field of view, and that's going to reduce the exposure time you have to record your spectra. So you want to make sure that it's exactly lined up with Polaris, and we have already done that at this point. The next thing we want to do is go ahead and remove the 4 eyepiece adapter from the back of the telescope and connect the extension adapter that should be attached to the diagonal. And there are 2 pieces to this. You want both pieces for this portion of the setup. And then we screw that onto the telescope. You then take the eyepiece out of the diagonal and you want to put it into the adapter as far as it will go. So there only should be a little bit of silver showing once you've put it in the adapter. And this is very important because when you focus the telescope, you want the focal point to be at a certain distance so that when you put the diagonal on, the fibers will be right where that comes to a focus, where the telescope comes to a focus. So you're going to push the eyepiece all the way into the adapter and then go ahead and put on the copper counterweight ring onto the front of the telescope. Then you can loosen up or unlock the axes and move your telescope around, but be careful because you do have this extra weight here. So it's not going to want to balance, so you're going to have to hold it here. But this is because once you find the object, you want to put it on a diagonal and you want it to stay exactly where it is. So for right now, you just have to be careful. So you move it around until you get close to your object, and then lock it back up. Look through the eyepiece and make fine adjustments with the 2 knobs of the telescope. And once you get what you're looking for into the field of view, you can center it in the field of view, and then use the focuser on the back of the telescope to bring the image to a nice sharp focus. So you do that, and if you have corrective eyewear on, keep it on because you don't want to have to compensate for your vision, so keep your eyeglasses on. So you look, you do that, bring it to focus, and then once you have it nice and focused, don't touch the telescope focus any longer. From this point, you want to go ahead, remove the eyepiece, unscrew the adapter. Again, being careful you don't touch the focuser. And then take apart the adapter. Then the piece that has the lock screws on, you keep that and you screw that back onto the telescope. With that screwed on tight, we'll then take the diagonal piece and place this end into the telescope. And the important thing to do here when putting this in is you want to have the lens tube, this long lens tube piece here, be parallel with these forks. So if you see here that there are 2 forks, one here and one here, you want to have the diagonal going perfectly bisecting them and being parallel with them. And this will reduce the torque on the motor. So you set that up here. Of course, you wouldn't have wanted to move this after you had already found your object. But just so you know, that's how you want to have the lens tube. So then you put the eyepiece into the lens tube. And make sure that everything is screwed down nice and tight because you don't want it slipping out. Then you should be able to look through the eyepiece and see your object. If it's not perfectly focused, again, don't touch the telescope focuser. You can actually loosen up the lock screws on the eyepiece and move the eyepiece forward and backwards through the lens tube and bring it to a focus. So you can move this until it's nice and focused and then lock it down. Now you have your object falling somewhere near the fibers. The task then is to use the fine adjustments on the telescope to guide that object towards the fiber end. The fibers go through a hole in the mirror that are larger than the fibers themselves. So you can guide the object towards the fiber only to a certain extent until it falls out of the field of view. At that point, you can't guide it any longer. This is why you're going to need 2 people for this portion of the experiment. So you have one operating telescope, guides the object close to the hole, and there's actually, for reducing thermal noise and background noise, you're going to have to take a couple of calibration images prior to actually looking for the spectra, but refer to the SPAN manual for details on how to do that. But once you've taken the background images and the thermal images and all that good stuff, then you go ahead and try to actually get the object into the fiber. So you guide the object towards the hole until it falls out of the field of view. From that point, you want to then have one person on the Orion camera studio who has the images looping through. At that point, you want to do fine adjustments, moving it in that void until something shows up on the software. Once that happens, you know that you have the star exactly where it needs to be. You can take your hands off the telescope and then increase the exposure time on the software and record a nice long image of the spectra. From then, you can take multiple images, you can stack them up, and then save them. You want to be very descriptive with the file names. You want to make sure that you record the temperature of the CCD, the exposure time, what it is you're looking at, of course, and those are the main things, because when you do your calibrations later, you want to know that when you're stacking it or when you're doing reducing the thermal noise, you want to use a 30-second exposure or 40-second exposure or 50-second exposure. You want to make sure you're using the correct exposure. And also for the thermal noise, you want to make sure that you're using one for the same CCD temperature. And again, so the details are in the, you can refer to the SPAN manual that has the owner manual for the Orion CCD, and you can read a little bit more on how to actually clean up your image. Initially, it's going to be pretty fuzzy, it's going to be a lot of noise, but you will be able to see a little streak. And if you want to see exactly where that should show up on the CCD because you're having trouble getting the star into the fiber and you don't know if you're looking at the right thing or what you're even supposed to be looking for, you can take your phone light or some other sort of light and shine it down the telescope. Of course, you don't want to be looking through the eyepiece, but shine it down the telescope and then see what happens when you take an image with the CCD. You should be able to see the little streaks show up for the different fibers, and now you know where you're looking and what you're looking for, sort of what you're looking for. It's going to be a little dimmer than having, of course, your light, your phone light at the end of the telescope, but at least you have a reference to where on the software it should show up. So once you record your spectra, you can move on to another object and take some more. Maybe you'll be able to get a few objects in one night, and then pack your stuff up and head back to the lab and try to make some sense of it. So that concludes the video tutorials. Again, if you have any further questions, talk to some of the Astronomy Club officers and read through the documents that other people have put through the manual based on their experience. And if you are out there and you find a better way to do something with this instrument, be sure to share that information with other students, and you can write up a document and throw it in the SPAN manual, and that way in the future others will know better ways to do this. So good luck again, and I hope you have some fun working with this instrument.